Okay. So I will talk a bit about how to run Python in batch mode, and that is on the compute nodes. And there is more than one way of running things on the compute nodes, as has been mentioned, and we will also look at that more with interactive work. But in this case, I will look at how to run Python in batch mode, that is with the submit files. So in this session, I will look at what are the UPPMAX and HPC2N clusters, what is a batch job, how to make a batch job, and also show a little bit about batch scripts, and then give you some examples and something for you to try out and how to run Python in this way. So here is a brief session about how the cluster hardware and system at UPPMAX and HPC2N works. And what is a cluster? You might have wondered that. And when you log in to either UPPMAX or HPC2N systems, that is on Rackham or on Kebnekaise, you will log in to the login node. So it's either the regular login node or it's a ThinLink login node, but it is a special landing node which has some differences to the compute or calculation nodes. And you cannot directly access the compute nodes. They can be accessed interactively, or you can run stuff on them with a batch job. So a cluster, that is a network of computers where each computer works as a node. And each node has several processor cores and RAM, and there's also local disk that we will call scratch, or it can also be called temp. And there can also be other things on these nodes. There can be GPUs, for instance. But for a regular type of node, so you have a core with a node here with some number of compute cores, and then you have some local disk, and then there is RAM or memory, and it is also connected to other nodes, both local nodes and also to the storage. So we have a storage that is sitting in another room, actually, at HPC2N, for instance. So all the compute nodes are connected together, and then that again has a connection out to the storage nodes, and it has a connection out to the internet as well. So you can, for instance, connect to it, to the login node. And the user will log in, as I said, to login nodes. You use SSH or you use ThinLink. It's not the same login node you land on, but it will be similar. There will be the same things installed, more or less. And the compute nodes are more or less the same as a login node, but there will sometimes be different things on them. There can be more cores. There's often more cores, and the GPUs. Those who have GPUs are the compute nodes. Some of them. None of the login nodes have GPUs, for instance, and there can also be more memory on the compute nodes or calculation nodes. The reason you will see that they are sometimes called calculation nodes and sometimes compute nodes is that HPC2N has decided to call them compute nodes, and UPPMAX is calling them calculation nodes, so the words will be used interchangeably. And you can run light things on the login nodes, but anything longer, parallel, or more intense computations needs to be on the compute nodes. And that also goes for things like MPI, as I said, the parallel ones, because you cannot run that on the login node. And for GPUs, there is no GPUs on the login nodes, so you cannot. But there are other reasons not to run stuff on the login nodes, and that is because there is limited resources there and everyone has to share that. So if someone is running something intense there, then it will be very slow for everyone. So if we see that people are running long, intense computations on the login node, we will shut down the job. So don't do that. And if you want to know more about what clusters are, then I have written a guide that is here that you can look at later. So what is common for UPPMAX's system and for HPC2N systems? Well, they both have Intel CPUs, and they both have a Linux kernel, and they are both using the bash shell. So let's look at them here. So first, there is Kepner-Kaiser, that is at HPC2N, and cores per calculation node is 28, except for a part that we have with some extra large memory that is 10 nodes. They have 72 cores each. And the memory per calculation node is 120 on most of them, but as you can see, it can go up to as much as 3 terabyte, and that is the large memory nodes. And then also Kepner-Kaiser has GPUs on a number of nodes. There is most of the old ones, which are K80s, and then we have some V100s, which are the newer ones. And the K80s are on Broadwell nodes, and the V100s are on Skylake nodes. And also the compute nodes is a mix of Skylake and Broadwell, and it's possible to tell it to run just on one of them if it matters for your computations. In addition, we have a few of the newer GPUs. We have 3 A100s and 2 MI100 from the AMDs, but those are not yet available to users. They will probably be available sometime during the fall. We are installing them and testing them. So for Rackham, and these three here, Rackham, Snowy, and Bianca, they are all at UPPMAX. And Rackham has 20 CPUs per node, Snowy has 16, and Bianca has 16. And Rackham has about the same amount of memory per node as Kepner-Kaiser's has. So it's 128, but there are some that has as much as 1 terabyte. Snowy has between 128 gigabyte and 4 terabyte. And Bianca is between 128 gigabyte and 512. And Rackham, which is the one we log into, has no GPUs. But we can submit jobs to Snowy, and that has NVIDIA T-Force. And the Bianca has NVIDIA A100. So, but that is the one for sensitive data. And you connect to that in different ways. So as I said, when you want to run longer jobs, parallel jobs, resource-intensive jobs, you have to run through batch scripts. And the batch system at both UPPMAX and HPC2N is called SLURM. And SLURM is what is called a job scheduler. It's an open source job scheduler. It has 3 key functions. It keeps track of all the available system resources. So it knows how many nodes there are, how many cores, memory, GPUs, etc., and which ones are free and which ones are in use and for how long and things like this. And it also enforces local system resource usage and job scheduling policies. So it keeps a queue, manages a job queue, distributes the work across it, the resources according to the policies. So yeah, that is what makes the jobs run. And in order to run a batch job, you need to create and submit a SLURM submit file, which also sometimes is called a batch submit file, batch script, or job script. So you will see all these when you look online, for instance. And we have some guides and documentation. There's here for HPC2N, and there's also for UPPMAX. And you can go look at that later if you want to. So what is the workflow? Well, you first write your batch script. And inside the batch script, you will load any modules you need. And here we will probably load Python modules. You will load Python packages, possibly prerequisites, especially at HPC2N and so on. You may possibly have to activate a virtual environment, isolated environment, if you have installed stuff yourself that you want to access during your job. And you can ask for resources then depending if it's parallel job, serial job, GPUs, etc. And then give any commands to your Python script. And when you have done that, you have written a batch script. And in this batch script, you will submit with sbatch and whatever you called it. It's common to put file extension for batch script as .sh or .batch, but it's not necessary. You can call it whatever you want to. This is just conventions that might make it easier for you to find them in your list of jobs. So let's look at a few useful commands to the batch system. So as I just said, this is how you submit a batch job. And if you want to see a list of your jobs, you use sq-u and your username. If you don't add -u your username, then it will give you a list of all jobs, and that can be very long, so it's not so useful. So it's better to limit it to your own jobs. To check on a specific jobs, you say scontrol show job and a job ID. The job ID you get either when you submit the job or from the list of jobs you found with SQ. You can delete a specific job with scancel and the job ID, and you can get more info about a job with the SACCT commands. And this here means it pipes it to another command, which is less -S. The reason for this is the output of this command here is extremely wide. And this extra command here makes it so that you are able to scroll sideways in your terminal window, which is very useful. And on Kepner-Kaiser, you can get a page with more info about the job as well with the command job usage and the job ID. It will give you a URL you can open, and that will then show you various graphs with resource usage for your job. But this is only for Kepner-Kaiser. So let's look at a few examples on Python batch scripts. Let's assume we have a Python script, for instance, this one here. It does matrix multiplications, so it's quite a simple script. And how do we run that at UPPMAX? Well, first we have this line here, which should always be there. Tells it to run in the bash shell. And then you have one line that always must be there as well. And that is a line that tells it which project it runs in. And this here, nice 2023 -22 -500, that is the project for this course here at UPPMAX. So you will run in this today, and it will also be valid for a couple of weeks more, I believe. And after that, you need to change it to your own project if you want to keep running. So that is this thing you change here. And then you also need to tell it how long do you believe it will take for your job to run. And here I'm asking for 10 minutes. It's hours, minutes, seconds, and at most a week in both UPPMAX and HPC2N. And you should attempt to ask for not too much more than what you need, because you will not be allocated to or your project will not be allocated for more time than what you actually needed. But if you tell it that you need 5 days and you only need 10 minutes, then it will take a long time for the job to start, because you will then sit in a queue and wait until there's actually 5 days long time slot open, whereas a 10-minute time slot might be something that's open very quickly. Also, remember not to ask for too little, because if your job takes 11 minutes to run and you ask for 10, then it ends after 10 minutes and you don't get your results. So it's you should ask for maybe a little bit more than you need, but not too much. And then we want to ask for some resources to run on, and this is a serial job, so I'm just asking for 1 core. And then we load any modules you need, and in this case, I'm going to load Python. and it's Python 395. And this is at UPPMAX, so there are no prerequisites. And at the end of the script, I'm telling it to run my Python script. Yeah, so that is quite straightforward. So let's look at what difference is to HPC2N. Again, you have this line here. There is actually a difference that on the UPPMAX one, you should always tell it to run with the login shell or whatever. So it's important to put -L here. That is not needed at the HPC2N. But the most important difference, of course, is that there's a project ID. And at HPC2N, it's a different one than at UPPMAX. Again, you just put yours whenever you use it otherwise. Again, I ask for 10 minutes, 1 core. I load any modules I'm needing. And in this case, Python 395 has some prerequisites at the HPC2N. It has GCC 10.3.0 and OpenMPI 4.1.1. Actually, it doesn't have OpenMPI 4.1.1 as a prerequisite, but SciPy bundle has. And I need that as well and to do this. And that is because there's a package that's included at UPPMAX that's not at HPC2N. Anyway, I then just run my Python script. So let's look at another example here. And this is also for running on a serial example, but in this case, I also have some packages installed myself with a virtual environment. So this is mainly to show you how it would look if you want to activate this virtual environment. And you do that. This so far is the same as it was before. And then we activate the virtual environment. You do it exactly the same way you would do in a terminal window. So you source the path to your virtual environment and whatever it's called, and then the bin directory, and then activate, just like you would on the terminal window. And then you run your Python script. And it's the same at HPC2N, there's no difference there. So what if you had a short GPU example that you want to run on Snowy? Remember, we are logged into Rackham, so we need to tell it to go to Snowy. And we do that by adding this one line here, -M Snowy, tells it to submit it to Snowy instead. And for this GPU jobs, I am asking for 1 node and for 1 GPU. Again, I load Python and then I run a Python GPU code. At HPC2N, it is a little bit different. You are not telling it to go to a different cluster because Kebnekaise has the GPUs, but you ask for GPUs in a different way. And the reason for that is that Kebnekaise has 2 different types of GPUs. So here I'm asking for K80. You could put V100 here instead, and it would ask for one of those. And then again, I load the stuff I need. This here, TensorFlow, would actually, this example here is running a TensorFlow example, and this actually loads Python also. You can do ML Spider on a module, and then you will see what it will load as well. So. And here are then some exercises that you could try and run. And before we go to that, I want to show you to make sure that you actually have these exercises that you need here. So there were 2 options. And I have, again, difficulty at getting to the top of my screen because of the zoom bar. Let's see, it's there. So I go here and I could clone this, copy it. And then I am going to do a git clone. as you can see here, then it's cloning into HPC Python. And I am at Rackham. And you can see I do an ls. What I have here is the directory it just cloned. These two, example and BPIN, are my two virtual environments that I created earlier. So I will go into HPC Python. And here I have a directory called exercises. I'm going to go into that. And then I will go to examples. And here you can see there's the program directory that contains the Python programs. There's an UPPMAX directory which contains batch scripts, submit scripts that you can run on UPPMAX. And then there is the HPC2N directory, which has the same thing for HPC2N. So here I will go to UPPMAX. Before I do anything else, I'm going to try and do something similar on HPC2N, but not quite, because I also want to show how you could copy the tarball. And I will just show you where it is. It is in this directory here. It's called Python UPPMAX on UPPMAX. So inside this directory, I have examples tar tz. I will go back to my own directory and I will do a copy. And I could simply take this long line here and then do Python HPC2N and then examples tar and copy it here. And now I have a tarball, as it's called. And I'm going to unpack it. I do that like this. Unpacked it. And then I got a directory that in this case just is called examples. And the reason for that is that it only contains this subdirectory examples here. So this is if you only want the exercises downloaded, you can do this. And again, you have programs, you have HPC2N batch submit scripts and UPPMAX submit scripts. See if I have anything loaded. Yes, I have the stuff loaded that I used for my virtual environment. So that means I have, for instance, the Python and SciPy bundle and things like this. And at UPPMAX, I have Python 368 loaded. So, and here I have an example that's called sum2args.py. And we could see what happens if I want to run that at HPC2N and also at UPPMAX. So in UPPMAX, I am in this directory here, and it is this submit script, which is this one. So let's open it and look at it. And this is how it looks directly. And I need actually to make one change here. I will put the L, but you can see here the project ID is correct. It's asking for 5 minutes, 1 core. And then I need to make a change here. You see here. Here you must put your own directory name. So I will put br this, which is me. And then this is correct. It is telling it to where it should look for the Python programs. And then I will load modules I need. And since this is UPPMAX, I only need Python. And then here you see the environment variable. This one is going up and looking at this environment variable. So what you have here, this will be put there instead. So it will run sum2args.py on 2 and 3. So I will save this. I will submit it. like that. And then I want to see if it is running. And you can see here, here's the job ID, same I got here. It's running on the core partition, and it's showing part of the name it has. It's mine, and this is the status. It's in status pending. And that means that it's currently waiting to get resources assigned to it. And here it shows how long it has been running. So when it starts to run, this will change. And it also says how many nodes is assigned and things like this. And let's see, you can see it's still waiting. So let's look at the HPC2N one meanwhile. I will again look at this file. And here you can see the project ID is changed. It's the HPC2N one. I asked for 5 minutes, 1 core. And now again, I need to go and change my path here. So I will do that. In this case, however, remember I did a copy of a tarball. So I did not clone it. That means it doesn't have the same path. That means it has a path that just looks like this. But otherwise, everything is the same. So let's go ahead and submit it here as well. And again, I see what it's doing. And here it seems it already ran. And you can also see I did an ls in the directory, and it has an output file that looks like this. So let's see what's inside this one. I will do a less on it. And because I did a purge, it also did all this. This can be ignored. But the correct output here is the sum of the two numbers is 5. And as you can see, that's correct. Let's see if it has a run. It's still not running on UPPMAX. So I will just leave it there and, well, show you that this is how it would look for UPPMAX. So the key points here is that the SLURM scheduler handles allocations to the calculation or compute nodes. And we will look at interactive work later, as opposed to, this is wrong. Here, it will be looked at later. And batch jobs run without you interacting with it while it is running, and that's an important thing to notice. You need to give it all the information that it needs to run. So a batch script, it consists of SLURM parameters, which describes allocations and resources, and a second part that describes the actual work within the job. For instance, it could be one or several Python scripts. And if these Python scripts have input arguments, you must add them to the submit script because you cannot interact with it while it is running. So that is important to know. But you can look at these examples here, and you can try to run some of them. You can try the matrix multiplication one, and you can try the sum of two arguments one if you want to. The other examples will be looked at more later because they are for the GPU parts and for the machine learning parts. But take a look at these two and see if you can get them to run. I needed to make this some small changes so it fits with the one that is shown here on the screen. So that is part of the exercise. Okay.